Our app is HeartBeatMap, and it's a way to detect heart disease using mathematical topology. And this is by Sachit, William, and Justin. So ventricular tachycardia is this condition where the heart beats abnormally fast, and this can be very deadly. And the current diagnostic tests are not efficient. So we wanted to try to use algebraic topology to resolve this issue. And through a combination of Hagen's embedding theorem and persistence homology, we were able to develop a machine learning model to use persistence diagrams to detect the difference between healthy and unhealthy patients.
So what is the purpose of this app? The application is designed to leverage topological data analysis for the detection of ventricular tachycardia, providing a novel approach to cardiac arrhythmia monitoring. Here are some of the tools and coding languages used to create this app. GeoTDA was used for sophisticated data analysis to extract features from the ECG data for ventricular tachycardia detection modeled using the methods mentioned by Justin. Streamlit allowed us to quickly build a user-friendly interface for medical professionals to analyze ECG readings for tachycardia. We hosted the HeartBeatMap on Onward for its effortless deployment and auto-scaling capabilities. Development and debugging of HeartBeatMap were streamlined using the versatile VS Code editor. Java handled the backend processing, interfacing the machine learning model with their application's front end. Python powered our ML model, utilizing its rich ecosystem to process and interpret ECG data for arrhythmia detection. CSS was key in designing a clear and responsive layout for the HeartBeatMap web application. Here are a list of people who we hope to target with our app: medical cardiologists exploring topological applications, researchers investigating mathematical approaches to cardiology, and academic professionals and students at the crossroads of biomedical engineering, applied mathematics, and heart health.
Now into the best part, the actual web app. As you can see here, we have lots of our project info here. On top of that, we have our code. That's our primary machine learning model. We use GeoTDA to implement this. And on top of that, we also published a research paper on JSM proceedings. As you can see here, it's over 20 pages of raw math. Give me a second as I scroll through all of this. And on to our main feature, the patient prediction. As you can see, I can just browse Excel files of ECGs to determine whether or not a patient is healthy. For example, this one will determine a healthy patient here. As you can see here, we see a time series data graph, as Justin explained, as well as a 3D plot of a circular nature. And just give it a second as the time series embedding pops up. There we go. Now let's take a look at another patient, preferably unhealthy. Patient 19. Give it a second as it scrolls through the Excel file. As you can see, it's an unhealthy patient. We see this by the time series data graph, as well as the 3D plot, which is very scattered. We also have the time series embedding through the persistence diagrams.